For question 5a, we are asked to differentiate the function from first principles. The way that I tend to do this is look at it graphically. In the first instance, we have a first coordinate of x, 2x squared minus 5x plus 3. And then what we do is we move a short distance across the x-axis, a very, very small distance, and we call that delta x. We can then generate two new coordinates, an x-coordinate of x plus delta x, and then a y-coordinate of 2 brackets x plus delta x all squared minus 5 x plus delta x plus 3, i.e. taking into account that movement of delta x across the x-axis. The next stage is actually, because we've moved such a tiny distance, we can work out the gradient of this section of the curve as we would work out the gradient of a straight line. So we're going to call it at this point delta y by delta x because we're dealing with such small movements. And this is, as you would do in any coordinate geometry question, is the change in y coordinate over the change in x. So in this case, the change in y is 2x plus delta x squared minus 5x plus delta x plus 3. Subtract 2x squared minus 5x plus 3. At this stage, it's important just to put the second y coordinate in brackets, all divided by our small distance across the x-axis delta x. In the first instance now, we need to just expand our brackets just to see what our result is, and on the numerator we're going to get 2x squared plus 4x delta x plus 2 delta x squared. I would tend to learn the result of multiplying out x plus delta x. It can be proved to be very useful. Minus 5x plus minus 5 delta x plus 3 minus 2x squared plus 5x minus 3, all divided by delta x. Now this looks quite a scary function, but actually when you look at it, we can see straight away 2x squared and minus 2x squared cancel, minus 5x plus 5x cancel, plus 3 minus 3 cancel. This leaves us with 4x delta x plus 2 delta x squared minus 5 delta x all over delta x. We can now see that everything has delta x in it as a common factor, so we can divide through by delta x, giving us 4x plus 2 delta x minus 5. Now, as I mentioned earlier, delta x was a generic movement across the x-axis, so what we could say now is dy by dx, as delta x approaches 0, our function therefore becomes 4x minus 5, because obviously the delta x effectively is going to become 0, so it plays no more part in that function. It's extremely important that you actually make this mathematical notation to show the examiner what you're talking about. Therefore, dy by dx is equal to 4x minus 5. A little check, you should already know how to differentiate. Our function was 2x squared minus 5x plus 3, so differentiating 4x minus 5.